So there are three types of prototype properties you will see in JavaScript. One is the prototype with this double square brackets. The other is the proto with two underscores. Now this one's deprecated, but we'll still talk about this one. And the third is the dot prototype property. So let's understand the first type of prototype with the double square brackets. So if I ever create an object in JavaScript, for example, let's say I've created a galaxy object with two properties, name and description. So I'm actually using the Chrome snippets tool here. So what I can do is I can run this and then I can add it to the watch, add selected text to watches. And what happens is when I create this object, I can see that this object has been created with the description and the name. And the third thing we see is the first type of prototype, which is the prototype with the double square brackets. Now if we expand this, we see that there's all sorts of different methods and properties available on this prototype. So this has been created automatically. All we did was to create a galaxy object with two properties, and JavaScript automatically has assigned it a prototype property which points to an object. So the best way to understand this would be to look at some diagrams. So we created a galaxy object with the name and description property, and it got assigned a prototype property which actually is pointing to an object. So for the rest of this video, we won't use the watch function within the snippets tool. We'll just use some diagrams, as I think it'll make way more sense looking at the diagrams than expanding those prototypes and dot prototype properties and looking at all of that. That could get confusing. So we'll just look at the diagrams from this point on. So what happens if I create another object? So let's say I create another object, this time local cluster, and this object also has the same two properties, name and description. So let me just run this. So in this case also, we've created a new object, local cluster. It has two properties, and then the third prototype property has been already automatically assigned to it, and this also points to an object. So the situation we have in front of us is we have created two objects, one called galaxy and the second called local cluster, and both these objects prototype properties now point to the object. So what if I want to create an object whose prototype property I want to point to one of these objects? So let's say if I want to create an object, let's just call it Andromeda, and I want this object to point to one of these previously created objects. So what I can do is I can use object.create, and I can pass the object to which I want its prototype property pointed to. So for example, this. So object.create and passing the object will mean that the Andromeda object's prototype property will now point to galaxy. Whereas previously we saw whenever we create objects like these two objects, its prototype property automatically points to the main object, the JavaScript object with the capital O. Whereas in this case, what I'm doing is I'm creating an Andromeda object and I'm passing the object that I want this object to inherit from. So I use object.create and galaxy. So let me just run this. So this basically creates a situation like this. Initially we created a galaxy object which pointed to the object, and then we created a local cluster object which again its prototype property pointed to the object. But then we created the Andromeda object by using the object.create and passing galaxy within the parameters. So in this case what we have done is we have made the prototype property of the Andromeda now point to the galaxy instead of to the object. And we can easily check this by only doing this. So we can console log and we can use the object.get prototype of method and passing in the object whose prototype we want. In this case, we want to make sure the Andromeda's prototype is pointing to the galaxy method. So if we run this, as we can see that it returns the galaxy object, and that's what we saw in the diagram. Its prototype now points to the galaxy object. What if we don't want the Andromeda's prototype to point to galaxy anymore and we want it to point to local cluster? So what we can easily do is we can use the object dot set prototype of, in this case, Andromeda, and we want to set it to local cluster. And if I run this, so let me just, now the console is printing out that the Andromeda's prototype is now pointing to local cluster and no longer pointing to the galaxy, because we've used the set prototype method to change the object to which the Andromeda's prototype is pointing to. And in the diagram, it actually looks like this. Initially, it was going towards a galaxy. Now we have used the set prototype method, and it's now pointing to the local cluster. So there are two main takeaways here. One is that prototype is a hidden property. We need some method to access it. We've seen some of the methods like get prototype off. We can also use different methods like set prototype off to set the prototype of an object. The other thing we learned is that prototype of an object points to the object that it descends from. So from an inheritance point of view, that opens a few possibilities for us, that we can now create objects that inherits from other objects. Now that we understand the prototype property with the two square brackets, the proto property that you may come across in the legacy code with the two underscore is exactly the same. So this is again a way to basically get or set an object's prototype. It's deprecated, so should not be used in the new code, but you may still come across in the legacy code. So object.get prototype of is the same as saying Andromeda.proto. It will return the prototype of Andromeda. And object.set prototype of is the same as saying Andromeda.proto and using the equals and passing the object to which you want the Andromeda's prototype to point. So exactly the same, and now you know how to basically interpret if you do come across this property. So let's now look at the third type of prototype property called the dot prototype property. And this will open the door to us understanding how JavaScript classes work under the hood and why JavaScript classes are called syntactic sugar, as the real work under the hood is actually done by functions. So let's create a function. This is a constructor function. It takes in the name argument. And if we run this and add this to the watch, so in this case, we see that we do still have the original prototype property with the two square brackets, but this time it actually points to a function, not to an object as we previously saw. But in addition, we also see that there is a new property which we didn't see before in the case of an object. We see a property called prototype, which points to a constructor object. So let's see what's happening here. We created our galaxy function, which has its prototype property. We have seen this prototype property before, but this time rather than pointing to an object, it's actually pointing to a function. Function in turn has its own methods available and its own prototype property, which points to an object. Our galaxy also has a new prototype property. We didn't see this prototype property when we created the objects like the local cluster and Andromeda previously. This prototype property points to a constructor object. The constructor object, it's no surprise, points to our galaxy because it's our galaxy constructor function. So it points to itself, which is good. But it also has a prototype property which now points to an object. So as you can see, all these linkages are established by just creating a constructor function. So let's say if I want to add a new method or a property to the rGalaxy function, how can I do that? Looking at this diagram, we can see that rGalaxy has a prototype property. We discussed this. So I should be able to add something to this prototype property. So rGalaxy.prototype.something, which could be a function or a property. And that way I can add a new method or a property to the rGalaxy function. In practice, it will look something like this. So we've seen we had the rGalaxy function, we are accessing its prototype property, and then we are adding a new property on that. In this case, it's a function. And running that, we'll get this. So now the description function has been added to rGalaxy. Now you know that how we can utilize this prototype property to add more methods and properties onto the rGalaxy constructor function. So now let's create an object using this constructor function, which we can do by using a new keyword. So we're creating a Milky Way object, new keyword, passing in the name of the constructor function and the name of the object we want to create. So if we run this, and then if I can add this to the watches, what we see is we've created a new object. And this object has the prototype with the double square brackets. It doesn't have the dot prototype property because we saw that when we create objects, objects do not get the dot prototype property. It's only when we created the constructor function rGalaxy, which had the dot prototype property. Now we expand this. We see that this has in turn 3 different properties. One is the prototype property with the double square brackets, which now points to an object. It also has a constructor function pointing to the rGalaxy constructor, rGalaxy function, and then it has the description function, which is this function. So as we can see, by using the new keyword and using a constructor function, we have managed to inherit the description method into our Milky Way. So I can now use the description method within our Milky Way objects. So as you can see, this is inheritance in practice. In the diagram, to make things easy, this is how it looks like. So we created a new Milky Way object using our constructor function. Its prototype property is now pointing to the constructor object, which we saw points to rGalaxy because it's an rGalaxy constructor function. It also now has access to the description method, and the prototype property we previously saw, and we saw in the snippets as well, points to an object. And as previously, now I can create more objects using the constructor function, and all these objects will now get access to the description method. So for example, if I create another object, it will have the same, using the same constructor function. So it has name, and then its prototype property will also point to the same objects. So as we can see, now I can use the rGalaxy prototype property, as we saw previously, rGalaxy.prototype, to add a description method, but I can add other methods as well. So this is really powerful when we have all these objects inheriting from a single constructor function. We can use the constructor function's prototype property to add a method or a property that we want available in all these objects. But what happens if I want to create a property or a method just for Milky Way? I don't want that method available in all the objects. I just want it available only within Milky Way. So that is actually quite easy, because let's not forget Milky Way is just an object. So I can just directly add a method to the Milky Way object itself. And that way the Milky Way description, the new method added, will not be available to Andromeda. It's only going to be available to Milky Way. So even when the dot prototype property is not available in Milky Way because it's just an object, we can just directly add methods as we normally do. So the next question arises, the way we created this constructor function, can we not use the arrow functions to create constructor functions? And the answer is we can't. So if I just show you, if I create an arrow function, let's say, and it's the same kind of function, it takes in the property name and like that. So let's just okay, so if we run this and get rid of that, and I add the text to watches, as you can see, there is no dot prototype property. We saw that that was a critical property when we actually created the constructor function using the old syntax. But when we use the arrow function, there is no dot prototype property. Secondly, within an arrow function, the this points to an window object. So the this will point to a window object. So therefore, we cannot use arrow functions when we are creating constructor functions. Okay, so what if I want to actually create a constructor function like this, and then I want to create another object that inherits with its own constructor function, and then I want to create another object that inherits from that, and this inherits from this. Now we can't do that in this case because we know that Milky Way is not a constructor function, so I cannot create an object that inherits from Milky Way. So how can we accomplish that? So let's create another constructor function. This time we just have two additional properties, description and planet. And just like previously, let's add another method to this constructor function. So the method we are adding is habitable. We saw previously we can use prototype property to add a new method. Now what this method actually does is it just basically checks for if it's a planet, and it says it's a planet with a certain diameter based on what we are passing and whether it's habitable. So we'll see this in practice. So let me just expand this a little bit. So the task before us is, now I want to create another constructor function which inherits from this constructor function. So what I can do is I can create another constructor function like this. So let me just create some space here, and I've created a constructor function called planet. It has the same three properties like name, description, and planet. The solar system has these three properties, but it has an additional property called diameter. So to make sure that the planet inherits from the solar system, what I can do is I can say solar system.call and then pass in this, and then pass in the properties, which is name, description, planet. So I can pass in the function itself and then the three properties. These three properties are available within the solar system. And then I can pass the additional property, which is only available in the planet, like this. So I can use something like this, and if I run this, and then if we now want to create a new object with the new keyword, which actually inherits from the planet. So planet, and I can pass in the properties, Earth, and let's just pass in false for now, and then pass in some value here. Okay, so I've created, let me just run this. I've created another object which inherits from planet. Planet in turn inherits from the solar system. So now logically we should think that Earth should now have access to the isHabitable method. So I should be able to run earth.inhabitable and get the results. So let's try that. Earth.isHabitable, and get rid of that. And it says isHabitable is not a function. So even though the planet inherits from the solar system, and then we used the same approach that we used before to create a new object from the planet, logically we were thinking that now we have access to the isHabitable function, because the chain works upward like this, from Earth to the planet, planet to the solar system, and solar system now has this isHabitable method. But that's not what happened. We actually got an error. And the only way we can properly understand is through this diagram. So this is what's actually happened. We created the solar system constructor function. Then we created a planet constructor function, and planet inheriting from the solar system by using the .call method. Then we created the Earth object by using the new constructor from the planet. So what we get is the isHabitable method is available here. And as we can see, there's actually no line basically linking the Earth's prototype property to this constructor object for Earth to be able to access the isHabitable function. And this is the reason we got the error. So we have planet, we have the same principle as we saw before. We have a constructor object, the constructor points to the planet. The solar system constructor points to the solar system, so that's fine. But the Earth's prototype is actually pointing to the planet, whose prototype is actually pointing to the object. So there's no line linking Earth to this constructor function, and we need to somehow establish this link for the Earth to be able to use the isHabitable method. So in order to fix that, what we have to do is planet's prototype property should be pointing to this object. So in order to fix that, what we have to do is we have to make sure the planet's prototype points to the solar system's prototype. Create solar system dot prototype. And just to make sure, so we're making sure that the planet's prototype points to solar system's prototype, which is this object. So they both should point here. Okay. And this should happen before we create the new object. So if you do this afterwards, it's not going to work, because this needs to happen before. That way Earth's prototype property will also point to the new object here. So that way Earth's prototype property will then also point to this constructor object. So this line should be written before creating a new object. So if I run this, as we can see, Earth now has access to the isHabitable function. And if we change this to true, and that's the first line of code, if this is true. Okay. So what did we just accomplish by writing that one line of code? So what we actually accomplished was we relinked. So we removed the incorrect link from prototype to this method, and that's where the Earth was pointing to. So we removed that link, and we got the prototype property of the planet pointing to this constructor function, and that was the aim. That way Earth's prototype now also points to this constructor function, and that's the reason Earth now has access to isHabitable method. So to clean this up, if I remove these linkages, now that's the situation right now. So this is what we have accomplished with that line of code. But looking carefully, there is still one problem here. Now, if we look at planet's prototype property, which now points to this object, that means planet's constructor is now pointing to solar system. But that's not good, because we want the planet's constructor to point to planet itself, not to a solar system. So that is also easy to fix. So all we need to do is write this one line, planet.prototype.constructor, and it should now point to the planet. So if I run this, and what this actually does is it basically points the constructor of the planet back to the planet. So as we can see that we can actually use the function constructors to create an inheritance. So we created the solar system function, we created a planet which inherits from solar system, then we created an Earth object which inherits from planet, and so on and so forth. But as we also saw, it is not that easy, and there is a lot of scope for error, because the prototype properties have to be repointed, and you have to do all these gymnastics to basically get this inheritance right. And I think this is a nice segue into JavaScript classes and why they came into being. They basically remove the scope for this error where we have to repoint the prototype properties and then repoint the constructors and all of that. To avoid all of that, we use JavaScript classes, and under the hood, it is actually all these functions that we use, and this is how the inheritance is actually working. So approaching this topic from a function point of view and actually seeing how the functions can be used for inheritance and all the work we have to do around them to make it actually work would make us appreciate JavaScript classes. So if we take the same example as above and try to accomplish it through JavaScript classes, we can see how easy it is. So for example, if I create a new class, and this class has a constructor method here, and this class also has a same is habitable object. So in this case, if I want a planet object to inherit from the solar system class, all I have to do is class planet extend solar system, and then create a constructor method and use the super syntax here, pass in the name of the properties which exists up here, and then exactly same to what we did before, and then I can add new methods within that. And then in this case, if I have to create a new object which inherits from the planet class, which in turn inherits from the solar system class, all I have to do is create the new object, and in this case there is no relinkages and repointings of the constructors and the prototype property we have to do. The isHabitable method is now straight away available to the Saturn object. So let's say I create this Saturn class.isHabitable. So let me clear that, run that, and there we go. So that kind of concludes the video for today, because the whole point of showing you was that using functions we can accomplish the inheritance and the prototype chaining, but it's actually very tricky. Whereas using the classes, it makes our life as developers way easy when we want to create objects that inherits from other objects, so on and so forth.